We'll have a look now at binary division, and before I do, I thought I'd do an example of base 10 division. So we're going to do 49 divided by 2. So we'd put the first number in the bus stop, if you can use this method, and the one we're dividing by outside. So we ask ourselves, will 2 fit into 4? So we look at one number first, and yes, it will. It goes in twice exactly. Next we say, will 2 fit into 9? And of course it does 4 times with a remainder. So because there's a remainder, I'm going to put a decimal point top and bottom and add some zeros to the fractional part of the 49. So 2 goes into 9 4 times, but remainder 1. So that 1, we ask how many 2's fit into 10, and it's 5, no remainder. So of course 49 divided by 2 is 24.5. And we'll use exactly the same method for binary division on the more difficult questions. So in this example, it's really simple. 1 0 1 1 1 base 2, so binary number divided by 1 0. But we know that when we're dividing by 2, which is what this number is in binary, to divide by 2 we shift the number right one place, because when we double a number in binary we shift it left. So if we divide it by 2 we will shift it right. So the answer is really easy, only because the number that we're dividing by is 2. It also works if we're dividing by 2, 4, 8, 16, etc., but only those numbers. The answer, shift everything right, means divided by 2. If you shift it right twice, you're dividing by 4. So the answer will be 1, 0, 1, 1. The radix point stays in the same place always, so the final 1 lives there. So what are the numbers to work out if we've got it right or not? Well, on the top number, units, 2's, 4's, 8's, and that's 16's. So we had 16 and 4 is 20, so this is 23 base 10, and we were dividing it by 2. Of course that's the units and 2's. So of course 23 divided by 2, or 22 divided by 2 is 11, so it's going to be 11 and a half base 10. So this number should equal 11 and a half. Let's work out if it is. So we have an 8, a 2 and a 1, so that's definitely 11 base 10. 0.1, but remember the next column in binary, if we're dividing units by 2, is the halves, so this is actually worth 1/2 because it's just after the radix point, so it's 11.5, so that's correct. So a bitwise shift to the right is a division of 2, and a bitwise shift to the right twice is a division by 4. If you shift it 3 times, you're dividing by 8. So these are easy ones to do if you're dividing by 2, 4, 8 or 16. So the next example looks a lot more difficult, but we'll be able to do it no problem. So we have whatever this number is, we'll work it out later, 110, 110, 11, divided by 110. So the same as with the bus stop method earlier with the decimal number, we ask, will 110 fit into 1? And of course not, because this is a 3-bit number, so it's going to be bigger than a 1-bit number. So we put a 0 there. Then we look at 2 numbers. Will 110 fit into 11? No, of course it won't. And then we look at 3 numbers together, the same as when we do base 10. Will 110 fit into 110? And yes, of course it does fit in once with no remainder. Because we've got no remainder, we just start with the next number. 110 will not fit in here. 110 will not fit in there either, looking at 2 numbers. But will 110 fit into the next 3 numbers? Yes, it fits in once. Then we keep doing the same method. 110 will not fit into just 1 on its own. It won't fit into 11 because this is a 2-bit number and this is a 3-bit number, so this has to be bigger. The leading one's there. So now we can't just leave it at that. We need to, like we did with more difficult base 10 division, at the top there we put a decimal point and some zeros. So we're going to put the radix point, we can't call it a decimal point in binary, and some zeros, we don't know how many we'll need yet, and continue the line over. So now we'll see, will 110 fit in to these 3 numbers? And yeah, because they are 110, so it fits in once with no remainder. Now I tried to work this out on the Windows calculator using programmer mode, but the answer doesn't give us a radix point on any fractional part, so we will just do it manually. So with the original number, there's the units, 2s, 4s, 8s, 16s, 32s, 64s, and 128s. So the original number was worth 128 plus 64, which is 188 plus 4, which is 192, plus 16, which is 208, plus 8, which is 216, plus 3. So it was 219 was the original number, and we were dividing that by 6. So using a standard calculator, 219 divided by 6 is 36.5. Yeah, so this worked well. But it was quite a basic example. So we'll do some more examples. So the next example is really quite tricky, but we need to bear in mind and remember what numbers are worth in the binary number system. So we have units, 2s, 4s, 8s, 16s, etc. So we'll take it from the top. So will this 4-bit number 1110 will not fit into 1? So you look at 2 numbers, it can't fit into 2 because it's the wrong bit length for starters. It cannot fit into a 3-bit number. So we look next. Can 1110 fit into 1011? And although it's a 4-bit number, and they're both 4-bit numbers, if you notice, they both have leading ones, but this has a 1 as a second digit, and this has a 0 as the second digit. So this number must be bigger than this one because they're both 4 bits long, but this has a 1 in the second column from the left, and this has a 0. So it will not fit into the first 4 digits. It won't divide into that. So we look at the first 5 digits. And now it becomes useful to work out what the numbers actually are. So 1 and 1 and 1 and 0 is 8 and 4 and 2 and 0. And you convert it to base 10 in your head. So the number that we're dividing by is actually 14 in base 10. And the number that we're trying to divide it into, well, that would be the units. So that's 2 plus 4 is 6, no 8 and 16. So 16 and 4 and 2. 16 and 6 is 22. So from there to there is 2 and 4, 16, which is 22. 14 will fit into 22 once. In fact, what I forgot to do, when it wouldn't fit into a 4-bit number, I forgot to put that 0 there. And now we're looking at the 5-bit number, that's 22. 14 fits into 22 once. And of course, there's a remainder. 14 goes into 22 once, and there's a remainder of 8. So the remainder, remember, 8 looks like this: 1, 0, 0, 0. So this is the remainder. So remainder 1, 0, 0, 0. So the number that we're trying to fit it into now is 1, 0, 0, 0, 1. And because we had a remainder of 8, this digit shifted it over once, so it becomes 16 plus the 1. So this is worth 17. And 14 will fit into 17 once, with a remainder of 3. And there's our remainder of a unit and a 2 is 3. But now we treat, as we do with base 10, we treat it as 111, which is 7. And 14 won't fit into 7. So we look at 4 bits. And of course, the 4-bit number here, 1111, in base 10, I'll write 10 there. I should have done it on the 17 as well. 14 will fit into 15. 1111 is 15. It'll fit in once. Remainder 1. So now we ask ourselves, will 14 fit into 10? Well, no, because 10 is 2, so it won't fit in there. Will it fit into 101? Well, no, 14 can't fit into that because 101 is worth 5. So now, although we're running out of space, we can continue underneath. I'll see what I can squeeze in. So this was the original number, and we have some left over. So we know we need a radix point on the top and the bottom. And I think at this stage it's probably worthwhile writing some of this further down so that we don't run out of space. So all I've done here, I've continued from the top right down here. So everything else will stay the same, it's just basically zooming in. So where we were at was, will 14 fit into 5? Because of course 101 would be worth 5, and no, it won't fit in. So we need some more zeros in the original number that we were dividing, the same as we do in base 10. So now we'll look at 4 digits. Will 14 fit into 1010? Well, no, it won't, because 1010 is 10 in base 10. So now we need to look at another digit column as well. 10100. Will 14 fit into that? Well, what's it worth? That would be the units, that would be the 2s, that would be the 4s, that would be the 8s, and that would be the 16s. So we have 16 and 4 is 20. This new number is worth 20 in base 10. Yeah, so 14 fits in to 20. So we will write, in fact I've done it again, I forgot to put the 0 when it wouldn't fit in here, and when it wouldn't fit into the 10, but it will fit into 20 once, with a remainder of 6. And remember, 6 is 110. So if 6 is 110, then 1100 has shifted it left. So this number must be equal to 12. And 14 won't fit into 12. So we need even more zeros for our remainder. We won't go on forever, of course, but this is the method that we would use. Eventually we would decide we had enough fractional part and we would round it. So 14 won't fit into 12. It'll certainly fit into this number with an extra 0 on the end. 12 is worth 24. And 14 fits into 24. It wouldn't fit into 12. It'll fit into 24 once. And 14 goes into 24 once, remainder 10. And 10 in binary is 1, 0, 1, 0. Now we ask, will it fit into 1, 0, 1, 0, 0? That must be worth 20 because this 0 shifts the 10 left. And of course we can see it's recurring now. 14 will fit into 20 once, remainder 6, which is 1, 1, 0. It won't fit into 12, and so on. So although it's quite laborious, what we can say, we got there in the end, is that 1, 0, 1, 1, 0, which is the question that we were dividing 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, divided by 1, 1, 1, 0 is equal to our answer. We don't have to write leading zeros, so there's the first non-zero part of our answer. 1, 1, 0, 1, 0, 0. Point, so the decimal point was there, 0, 1, 0, 1, 1. How far we go on depends on how much time you have, really. A few fractional parts would be good, 2 or 3 places. I can't say decimal places, but 2 or 3 binary places. And of course we need to check our answers, and I can reassure you that that answer is definitely correct. We've rounded it a little so that we didn't need to carry on even longer, but none of the calculators I've used seem to work with this on a computer or online. But if you want to get an app on the Google Play store, the one by Trasco Studios called Binary Decimal Hexadecimal Octal Converter works really well and gives you the remainder as a binary string as well.